Hey, I'm Frank Zagarella. I'm the electrical shop department head at Northeast Metro Tech. We're going to have a demonstration on some electrical wiring here today at Revere TV. It's important to always remember that electrical wiring is dangerous and it should always be done by a licensed electrician, and to ensure that they have a permit from City Hall. So we're going to have two different teams wire two separate projects. The first project is going to be a switch and two lights. The next project is going to be receptacle outlets. So the students are going to tell you a little bit about the program and introduce themselves.
Hi, I'm Sal Zagarella. I'm a senior and I'm from Malden, Massachusetts.
Hi, I'm Sophia Aquino. I'm from Revere and I'm a senior.
I'm Peter Lanzillo and I'm from Saugus and I'm a senior.
Hello, my name is George McKinnon. I am a senior and I'm from Chelsea.
So at this point, we're going to break it over. Actually, they'll tell you a little bit about the program. So we'll start with Sal.
Alright, so freshman year, you go through 16 different shops and you get to pick one. We picked electrical, so we're going to go over that.
And then once you get more into your sophomore year, you get to work more with EMT and RMC and learn the basics of cutting and where to place it and bending it. EMT is more for indoors and RMC is more for outdoors.
In our junior year, we have a thing called Out Crew, where you get to go to real jobs and get a real working experience.
Co-op is a fundamental to life. It will help you get introduced into the real field by connecting with real contractors and licensed electricians, and that can give you a pathway to learn how to use the tools, get general knowledge about the field, and then if that goes well, then later on after you graduate, you might even stick with the same company as you had in high school.
So we'll go ahead and get started. We're going to start with the first team, George and Sal, and they're going to show you the circuit with a switch and two lights. So team one is going to be wiring a switch, a single pole switch that's going to control two lighting outlets.
Hello, my name is George, and this is
I'm Sal.
and today we are going to be demonstrating a single pole switch to two lights. Very understandable, and the way that we're going to use this is we're going to use screws, lights, lamp holders, tools, and most importantly the power, which we're going to connect it to. So right now we will be demonstrating how to do that. So right now we are making a pathway of electricity from our power source into these lights. So we're getting a power, putting it to the switch, and that switch controls this light and also this light at the same time. So we have to make sure these are tight to make sure that they don't fall out. Send the wire through. And he is bringing the feed from this light to over here. And once we have it in place, hammer it in. Same as to go over here. We are going to need a grounding jumper, which means directly from the box, I will need a ground. I'm just tightening up the screw, make sure it doesn't fall out. Now with our lamp holders, there's a ground on them, which means we just splice three wires, make them all the same length. I tend to usually do the ground first, get that out of the way, because more than likely you're not going to be touching it for a while. Have a ground, put the wire knot on it, that secures the wire. Now here, we're gonna need a pigtail, and what a pigtail means is we're gonna need to splice 3 wires together. These 2, and then a black one coming out, which goes to the light, because we need to send power from this light to that one. So right now, this one goes here. Which means we're gonna strip these blacks to expose copper. And copper and aluminum is allowed. However, copper is a better conductive, which is why I tend to use copper more. And then from the box, the wire needs to be at least 6 inches, which is roughly about, I like to go from palm to finger. That's what I tend to like to use. So that's roughly 6 inches. And then this white wire is also going to be the same thing. And he doesn't need any of these pigtails because there's no other place for that wire to go and travel.
So I'm putting the 832s into the box so that the mud ring will fit on the 4-inch deep. You wouldn't need to do that if it was just a box for just the light.
And I just like to make the neutral and the power about the same size. And from here, we're going to put in the mud rings. Do you have a Phillips?
Oh yeah, here's.
Now over there, what Sal is doing is giving us power to this project with the outlets that is in the wall, and then we just tap in from there. That's all. Now that box down there is a junction box, which is simply just splicing color to color, which is ground to ground, neutral to neutral, and black to black. Only in very few cases that white will be power, and that would be if you have Romex and you have a 3-way switch or a 4-way switch, which is then the white and red would become the travelers. However, more than likely, majority of the time, the white will always be neutral, which goes back to your panel. And then And the common practice I like to do is right at the termination, I like to squeeze the wires to make sure that even if for some reason the screw might become loose, that it will stay in contact. Such as an earthquake, or a tornado, or natural disaster, any of those sorts. That's good. And then gold is usually power, white is usually neutral. As you can see, white to white, gold to black. And when you're putting these in, you want to make sure they're as neat as possible, so that you will not have the possibility of nicking a wire. Or if the next guy comes, he's not like, oh my goodness, look at all this. It's a huge mess. This is actually a brand new one.
Yeah, mine didn't fit either. Mine wasn't fitting.
Okay.
You want to show me how to do this one?
What this metal ring does is allow us to keep this lamp holder onto the box, because they are obviously different shapes. And there, what Sal is going to do is, these are what connects to the wall, which gives us power. So he's going to strip these, and then he's going to go color for color. So right now, switch is off. Power is always constantly going to this gold screw right here. Once we switch it on, lever connects these two golds and sends power through the black wire, and then back through the white, and then back to the panel. Put that one.
Yeah. You want to explain to him how to do this one?
Because the neutrals we don't use on a switch. This one's gonna go down. Oh. And from here, boom. And then we typically want to make sure that the power's at the bottom, because it says off right here, which means when we turn this on, that it will be facing upwards and the power's gonna be coming out through the top screw. And as I said, I like to almost give it a crimp just to make sure that it'll stay on. And then this last ground will be going to our switch. As I said before, I just give it a little squish. So right now, this is our feed. This wire, because right now it's an off, it will be going in this lower screw. Thank you. Because this one, the top screw, this one will be going out. This will be our power to both of our lights. So now we have this cover back in place, and then I tend to usually always double check just in case. So this is our feed, going to the bottom of the switch. And once we turn it on, power gets sent over here to this light, to that light. So now, I tend to organize it as best we can inside of the box to make sure it's all nice and tidy. We use these 832s.
So the students have completed the project. Our last step is to see if the project works. As you see, both lights came on. Great job, guys. And we're going to move on to our next team.
Thank you.
Team 2 is going to be wiring 2 receptacle outlets on this project board.
Hi, my name is Peter,
And I'm Sophia.
and today we're wiring 2 outlets. They're both going to be constant power, and yeah, we're going to show you how to do it. So first, you need to have the feed to come through the bottom so you can get the power. And then we'll bring another wire through here so we can connect these two so we can add power to both.
So now he's adding the other wire in.
Alright, so I'm adding the wire to connect the 2 boxes so it can pass through the power, so both of our outlets can be powered up.
And after he's done with that, I'll add a staple just to support.
So now as we put the wires into the box, we have to tighten them down so there will be nothing loose and it can't leave out of the box.
So now he's gonna be getting a ground wire so he can add it into the ground. So we can ground it. So for this, he's adding an extra wire into the grounding because he does need to connect it into the outlet.
We can start working on our neutrals in our power.
So now he's doing the final picks. He's adding the final one so we can add the outlet.
Now that we have everything all spliced and all set up, we just need to add our terminal loops to our device. Now that we're done with the outlet, Sophia will start the next outlet.
Okay, so I'm gonna start off by first putting the staple in. Oh, this is just not. And now I'm gonna strip the wire. So now I'm gonna add my ground wire. So the difference between this box and this box is that I'm not adding any more wire. I'm just gonna do my terminal loops and add my outlet. And the last step is to add my ground.
Now that the ground's on, all that needs to be added is the cover, and then it will be all ready for a test.
So the students finish wiring the two receptacle outlets. The next thing to do is to check for correct wiring and see if the outlets work. We'll get two indicator lamps here if it's wired correctly in this plug tester. You can see the two indicator lamps. Tells me this receptacle outlet is wired correctly. And you can also see it on this receptacle, the two indicator lamps. Good job. The project works.
Thank you.
So that wraps up our demonstration. Thanks for watching.
Thank
All
you.
nights.
Have a good one.
Thank you.
Have a good one.